Hello everyone and welcome back. Now today again we are going to learn one very important topic on linear algebra, which is called linear transformation. So let us see what is transformation. So transformation is nothing but one kind of function. So what to take first? Let V and U be two vector space over the same field F. Okay. So कैपिटल V और कैपिटल U दो अलग अलग वेक्टर स्पेस है, लेकिन जो फील्ड है वो क्या है? सेम. तो सपोज इफ वी सी हियर two different vector spaces, suppose one is V, another one is U, but you see the field is same. Okay, field is same. Then what is T? Now T is a function from U to V, sorry, V to U. Okay, T is a function from V to U. So we know the function, the definition of function. If for every element of V, there exists a unique element in U, then we say that it is a function. Now this particular function is said to be a what? Linear transformation. Okay. तो इस function को हम linear transformation कब बोलेंगे? If some conditions are satisfied. जैसे कि number 1, T of x plus y should be equals to T of x plus T of y for all x comma y belongs to domain. So our domain is what? V. तो भी आप लोग देखिए, suppose we have a element x, तो x का जो image है वो क्या होगा? The image of x is T of x. And if we take another element y, the image of y will be what? T of y. Now since this is a vector space, what is the first condition? Closure property under addition. तो वहाँ पे क्या था? If we take two element from V, suppose x and y, two element in V, so उन लोगों का जो एडिशन है x plus y, वो भी कहाँ पे रहेगा? V में ही रहेगा. So it's a new element now. X plus y is a new element. So the image of x plus y is what? T of x plus y. Now if this T of x plus y is equal to T of x plus T of y, then this is one condition for what? Linear transformation. Now there is one more condition. T of alpha x, alpha is a scalar, so this can be written like this, alpha into जो constant है वो बाहर आ जाएगा, T of x for all x belongs to V and alpha belongs to what? F. So if T satisfies these two condition, then you say that T is a what? Linear transformation. Okay. Suppose मान लीजिए दो condition हमें नहीं लिखना है, हमें सिर्फ एक ही condition में लिखना है. So, or we can write only one condition. The condition is like, look like this. T of alpha x plus beta y is equals to what? Alpha into T of x plus beta into what? T of y. For all alpha beta belongs to F and xy belongs to what? V. So this is another condition. So when you do some examples, we'll use the second one because only one condition है, एक ही condition है, so एक condition देखने से हो गया. But if we do this part, then we have to do two conditions separately. So it's better when you do some example, we use this one, the second one. So it's very simple. What is linear transformation? Linear transformation is nothing but a mapping between two vector spaces, two different vector spaces, satisfying this particular condition. After linear transformation, we have linear operator. Linear operator. So what is the difference between linear transformation and linear operator? In linear transformation, the function is from one vector space to another vector space. But in linear operator, it is same vector space to same vector space. Okay. Domain is also V. Codomain is also what? V. So whatever you take, it will be same. If you take, suppose R cube, then T will be from R cube to R cube. Domain and codomain what? Same. So if this is V, this is also V. Then this particular function T, then T is what? A linear operator if T of alpha x plus beta y is equals to what? Alpha into T of x plus beta into T of y. Condition is same. Okay, the condition is same, but the difference is what? Same vector space to same vector space. There is one more which is called linear functional. Linear functional. So in linear functional, T is a transformation from V to field. Now here there is only one vector space and the domain is what? The function is from vector space to the field. Okay? So जो डोमेन है वो आएगा v एंड व्हाट इज द कोडोमेन विच इज फील्ड, जो स्केलर होगा. सो यहाँ पे t जो ट्रांसफॉर्मेशन है वो जितना भी यहाँ पे वेक्टर्स है, वेक्टर्स के साथ स्केलर का जो रिलेशन है वेक्टर और स्केलर में यहाँ पे रिलेशन आएगा. देन t is linear functional if again we use the same condition, t of alpha x plus beta y is equals to what, alpha into t of x plus beta into what, t of y, where alpha and beta are from the field and x and y are from the what, domain. Okay, so linear transformation is very simple, but if you don't know the concept of function, then you'll get a little bit difficult in the beginning. So I'll suggest you finally you just read that part, function, the definition of function. So from class 11 onwards you have the definition of function. So just go through the definition of function, then you see that it's very easy. Okay, now we are taking two different vector spaces. One is r cube, so this is the capital V, and another one is what, r square. So this is our u, two different vector spaces, r cube and what, r square. But you remember one thing here, what we said, if they are same vector space, no, suppose v to v, then we say that linear operator, but you can say linear transformation also, because linear operator is a part of what, linear transformation. Okay, now here what is the function? Since it is r cube, see, this is our domain, this is our codomain. Domain is r cube and codomain is what, two dimensional, which is r square. R means set of real number. So if you take a element x, y, z here, its image will be what, t of x, y, z, and this t of x comma y comma z is given like this. It will be x plus y and then what, y plus z. It is given in the question. We have to check that t is a linear transformation or not. Okay, so here t is a function from what, r cube to r square, defined by, okay, defined by, what is the function given? T of x comma y comma z is equals to x plus y and then what, y plus z. So here x, y and then z all are from domain. Domain is what, r cube. We have to check that this is what, linear transformation. So to check the linear transformation, if you go to the definition again, you see we need two variable x and y. Okay, two variable x and y, and you need two scalars. So let us take two vector and two scalar. So where from we'll take the vector? From the domain. Our domain is r cube, so they will be all two dimensional. So let us take u equals to suppose x1, y1, z1, and v equals to x2, y2, and then what, z2. Since they're three dimensional, that's why you have to take like this. Belongs to what, r cube. Individually, if you say what is x1, y1, z1, x1 is a real number, y1 is a real number, z1 is a real number. But when you write together, they will come in r cube. Similarly here also x2, y2, z2, they are individually what, real number, but together they are from r cube. And let us take two scalar. Suppose alpha and beta belongs to what, field. Here the field is what, r. So what to show? We have to show that t of alpha x plus beta y is equals to alpha into t of x plus beta into t of y. So it's better if we find left side and right hand side separately, then there is a very less chance of doing mistake. So let us find t of alpha x plus beta y. Okay, so before that, alpha u plus beta v, let us write it separately, find it separately, alpha u plus beta v. So alpha, our u is x1, y1, z1, beta into v is x2, y2 and what, z2. Now if you write in one bracket, if you combine them, it will be alpha x1 plus beta x2, first element, alpha y1 plus beta y2, alpha z1 plus beta what, z2. So three element, 1, 2, 3. So this is belongs to what, r cube. Now find the transformation, alpha u plus beta v. So it's t into alpha x1 plus beta x2, alpha y1 plus beta y2, then alpha z1 plus beta z2. Now see, this is our x, okay? This term is x, this term is y, and this term is what? Z. So it look like this, t of x comma y comma z. Now what is given in the question? You see, this is important. This part, t of x comma y comma z. What will be the right hand side? First x plus y, okay? First x plus y, and second element is what? Y plus z. That is how we'll express the transformation. So since this is our x, this is y, and this is z, so what they are saying, it will be first x plus y. So alpha x1 plus beta x2 plus y. Our y is alpha y1 beta y2. Okay, first x plus y, then y plus z. Alpha y1 beta y2 plus alpha z1 plus beta z2. Okay, so if you want to do more calculation, then you can do like, you can take alpha common, then you will get x1 plus y1, and after taking beta common, x2 plus y2. Here y1 plus z1 plus beta into y2 plus z2. Okay, if you want, then you can write this line, or you can keep it here also, no problem. So this is our left hand side. Now what is the right hand side? Alpha into t of u plus beta into t of v. So alpha into t of, our u is x1, y1, z1, beta into t of, what is v? x2, y2, and then what? z2. So again, the transformation definition will write alpha. So here this is x, this is y, and this is z. So what is the definition? Or so what is the function provided to us? First we have to write x plus y, means x1 plus y1, and then y1 plus z1. y1 plus z1. So this will be given in the question, don't worry. Then again, here this is x, this is y, this is z. So first we write x plus y, means x2 plus y2, and then we write y2 plus z2. Okay, so if we combine them, so first will be alpha into this. Okay, so it is alpha into x1 plus y1, and then here beta into this plus beta into x2 plus y2. Okay, comma, then this alpha into this second term, alpha into y1 plus z1 plus now beta into this. So it's beta into y2 plus z2. Now if you see this line and this line, see exactly same. So what you can say now? Therefore t of alpha u plus beta v is equals to what? Alpha into t of u plus beta into t of v. For all u v belongs to R cube and alpha beta belongs to field. Here the field is what? R. So the condition is satisfied. So therefore T is linear transformation. It's very simple. Okay. Any kind of problem comes, you just find the left hand side and right hand side separately. And if it is equal, then transformation. If it is not equal, then it is not a transformation. Let us take one more problem. Now here you see domain and codomain same. So we have to check that this is linear transformation or not. Maybe you are thinking that they are same. So why they are not linear operator? Yes, that's why that is what I am saying, that you can say linear operator also, but linear transformation also, because linear operator is a part of linear transformation. Okay. So here domain is R cube, codomain is also R cube. Now what is the function given here? If we take one element here, suppose it's R cube. This is R cube. The function is what? T. So if we take a element x, y, z here, its image will be what? T of x, y, and z. So how we can write this x, y, z? First element will be twice x, then y plus z, and then what? 3. This is the transformation they are giving. So now we have to check that this is linear transformation or not. Okay, so here T is such that R cube to R cube defined by T of x, y, and then z is equals to twice x, y plus z, and then what? 3. So like earlier, let us take two element u, x1, y1, z1. v, x2, y2, and then z2, they are both from domain. Okay, they are both from domain. And take two scalars, alpha beta belongs to R. So though it is not mentioned here, but the field is what? R. Alpha beta belongs to R. So first you find alpha u plus beta v. So our alpha u is x1, y1, z1, and then x2, y2, z2. So if you combine them, how will you write it? Alpha x1, beta x2, alpha y1, beta y2, and then alpha z1 plus beta z2. So now let us take the transformation T of alpha u plus beta v. So this is your T, beta x2, alpha y1, beta y2, alpha z1, beta z2. Okay. So this is x. Okay. This term is our x. This is y, and this is what? Z. So it is, the form is what? Concept form है T of x comma y comma z. So what is given there? T of x comma y comma z. You see the first term is twice x. So it will be 2 into our x is alpha x1 plus beta x2, twice x. Second term is what? Y plus z. So this is our y, alpha y1 plus beta y2 plus z. Z is our alpha z1, beta z2. And the last number is what? Only 3. It is given in the question. It is 3. So let us keep it like this. So our left hand side is done. Now coming to the right hand side, alpha t of u plus beta t of v. So alpha into t of u is x1, y1, z1. And then beta into t of x2, y2, z2. So again the same definition will apply. 2x1, then y1 plus z1, and last element is what? 3. Here also beta into first element is 2x2, then y2 plus z2, and then what? 3. Now if you combine them, see, if you combine them, what is the first element? Our first element will be this into this, na? 2 alpha x1 plus this is 2 beta x2, and then this element and this element. So it will be your alpha into y1 plus z1 plus beta into y2 plus z2. What is the third element? Here you see 3, here you see 3. So it will be 3 alpha plus 3 beta. Okay. Now if you observe, then you'll see that here when you find T of alpha u plus beta v, the last element is 3. And here the last element is different. So that means what? It's not a linear transformation. So how will I write now? Therefore, T of alpha x plus beta y, T of alpha u plus beta v is not equals to alpha into T of u plus beta into T of v. So therefore, T is not a what? Linear transformation. So it's very simple. If both the sides are equal, then transformation. If they are not equal, then they are not what? Linear transformation. So I'll suggest you find left hand side and right hand side separately. In some book you will see that from the left hand side they are trying to find right hand side. That is also okay, but maybe in some problem you will stuck in doing calculation. So it's better if you find left side and right side separately. Then it's very easy. So I hope the concept of linear transformation is very much clear to all of you. And thank you for watching today's video. So if you found this lecture helpful, then kindly share with your friends also, and also hit the notification bell so that you get updated with my all latest upcoming videos. Thank you once again for watching.